All right, this will be the last section in Chapter 11, 11-7, dealing with similarity between similar solid shapes, such as prisms or pyramids or cylinders. The main thing we need to think about is, in the past, when we had similarity, we were dealing with two-dimensional shapes, like triangles or things like that. Now we're dealing with three-dimensional shapes. So if I have a cube like this, and that cube is similar to a larger cube like this, what this means is it's going to be similar in every area. And so if we have 2, 2, and 4 for height, we might have 6, 6, and 12 for height. Okay, well, the scale factor should be obvious. 2 to 6 is equal to 2 to 6, which is equal to 4 to 12, but the actual scale factor is 1/3. And so you'll just need to keep in mind, guys, that when you're dealing with scale factor, it's the same as what we've dealt with previous. Just make sure you line up the proper things. In this case, it was a square base. Each side had a 1/3 ratio, and the height also had that same 1/3 ratio. Where this section becomes difficult is when you're changing it into area from a single scale factor ratio into area and volume, because area and volume are either squared or cubed. And so that usually tends to give students a little bit of problems. So I'll try to solve those questions or answer those questions before they're even asked. For example, if you've got two shapes that you know are similar, the volume of one is 729 centimeters cubed, and the volume of the other is 1331 centimeters cubed. Okay, so we know these are similar, which means a ratio of A to B. Okay. The problem is they don't give us the ratio of A to B. What they give me is A squared over B squared A cubed over B cubed, because they gave me volume. And so let's just put 729 over 1331. If I want to find the original scale factor, I've got to take cube roots of everything, and then I get my A to B ratio. So you're going to need your calculator, and I'm going to remind you how to find cube roots. You'll hit the math button, which is right underneath the green alpha key. Go down to option 4, and there's your cube root. Punch in 729, and the cube root of 729 is 9. But then you've got to do the same thing for the cube root of 1331. Hit the math key again. Option 4 is a cube root, and you'll find that the cube root of 1331 is 11. So my original scale factor was 9/11. All right. Let me erase this, and we'll get successively more difficult. It just depends on what you're given and what you're going into. If you're given a scale factor and you're turning it into a surface area scale factor, square both top and bottom of the scale factor. An example of this would be the 1/3 that we had previously. If we've got a 1/3 ratio between all of those sides or the height, then if we compare their, it's not really equals to, I guess I shouldn't put equals here, but if we compare their surface areas, well, I'm going to square both of those, and the ratio will turn to a 1/9. If I'm going to compare their volumes, then I'm going to cube both top and bottom, and that ratio will turn into 1 to 27. But those are all based upon the original 1/3 ratio. All right. So here's the most difficult type of problem, and this can be a little bit convoluted for everybody. So let me try to break it down as best as I can. I've got two paint cans. I'm not even going to draw them to save time, but these two paint cans are cylindrical shapes. Okay. And I've got lateral area of the bigger paint can is 1019 centimeters squared. And then the lateral area of the smaller paint can is 425. Still centimeters squared. All right. They say that the volume of the smaller can is 1157. Well, that did not work with my equals. So it's 1157 centimeters cubed on the volume. So what I've got to do is figure out the original scale factor and see, the question is, what's the volume of the larger can? Okay. Well, the easiest way to do that is to find the original scale factor. So lateral area is something squared. What I have is lateral area over lateral area. I have a squared over b squared equals 1019 over 425. But if I'm going to turn that into my original a over b, I've got to take the square roots of both. And so now I've got my scale factor a over b is equal to this really ugly looking square root of 1019 over square root of 425. Because there's no perfect squares in there, I'm just going to leave them as those ugly square roots. But then I have to do volume of the large a cubed over the volume of the small, but they give me the volume of the small. The volume of the small is 1157. And that's equal to the original scale factor, which is this really ugly square root of 1019 over the square root of 425. But I have to cube those square roots. So there's the setup of this problem. Basically, what I've got to do, guys, to solve for this is I've got to multiply both sides by this 1157, and I'll find my a cubed. And my a cubed is the volume of my larger paint can when it's been expanded under this ratio. So I'm going to multiply this by 1157 on both sides, and then I'll have my a cubed solved. So a cubed is equal to this really ugly number times 1157. Here's the way I would do it on your calculator. I would take, first of all, the square root of 1019. Just hit enter and then hit the caret and cube. Or you can use the math key and cube it. So the square root of 1019 cubed is this 32,528 figure. Leave that in your calculator. Hit divide and use parentheses. Parentheses, the square root of 425. You have to hit the right arrow key to get out of the square root sign, then hit the caret and cube that number, then hit the arrow again to get out of the cube and close the parentheses. Just look at your calculator and be careful with it, but we've got to do all this in parentheses to make sure we go through the order of operations properly. Hit enter on that, and now you've got a ratio of 3.71 never-ending decimal. Multiply that, which is an exact number, times 1157, and now you know that your a cubed is equal to 4295. It doesn't really say how much to round it to, so I'll just round it to 2.48 centimeters cubed. And that's the volume of the larger paint can. This is a very complex problem and involves multiple steps. I would highly suggest that you go ahead and look at the book after listening to this and kind of go back and forth from the book problem to the exercise that I've just shown you and see how you set up the ratios between single ratios of scale factor, to the squared ratio to the cubed ratio. And in this case, that is my volume right there of the larger can. All right, guys, that gives you at least an example. I think you'll do fine with it. There will not be that many questions on the test, probably 2 or 3, but this should help you get prepared for it. If you have any problems, please just see me in tutoring tomorrow on Tuesday. Hope you guys have a good week. Talk to me if you need help, and I will see you again soon.